In this second tutorial, we consider how the network mask and the IP address allow a machine to determine where to send a packet. Again, we're only considering IP version 4. We start by looking at how a network address is composed. Every network address is a composite of two parts. The first part is the address of the network itself. Although a network will have several devices, the network portion of their addresses must remain constant. The second part of a device's address is referred to as the host part. The host part is unique among devices, and it ensures that no two devices have the same address. How do we determine what part of the address is the network part and what part is the host part? So we have an IP address here, and we'll break this down into binary. This is what a computer looks at. Now, how do we determine which part of which of these bits is the network part and which is the host part? So what will happen is there actually is a division. You can think of it as a line, and everything on one side of the line, actually on the left, becomes the network part, which is unchanging for all devices, and on the other side is the host part, which is unique to every device. Well, this is accomplished. Finding this division point is accomplished by the network mask. We'll illustrate that here. So let's suppose in this network, this machine uses, or this network uses this network mask. We're going to convert this to binary here. And wherever we have ones, this is all the network part. So in our example here, our division between host and network is right here. So this is all the network part. Of the address, and this part here is referred to as the host part. Now, network masks always have a series of ones, and then they change to a series of zeros. They never have ones and zeros in the network part. Because of this, we can actually have a different notation. Sometimes you won't see an IP address and network mask. Sometimes you'll see just a network address, a slash, and then a number for the number of ones. So for instance, here we have 8 and 8 and 8, or 24. So if you see an IP address where you have an address slash and then a number like 24, that means a network mask. The first 24 bits starting from the left-hand side, those are all ones and the rest are zeros. So this is also a shorthand notation that gives us a network mask and the IP address. So now let's look at an example of how this plays in an actual network. So here's an example of two networks. So let's explain what we have here. This is one network, and the network address is 130.222.0.0, and we'll talk a little more about a network address a little later. We're going to show two actual networks. Each one of these would be considered a local area network, or LAN. Now, in order for there to be packets or communication between the LANs, we need something called a router. And the router's job is to simply send packets between these two devices. A router has to have an actual network interface in each of the LANs. And so you'll see that you have a network device with an address here, and we call that the gateway. So the gateway is the address of the network device. That is actually what's called a port on a router. We have to have two of these because we have two LANs. Now we're going to consider this machine here. And let's suppose this machine wants to send a packet to an IP address. So let's suppose the destination address is 130.300.34.22. So this machine has to make a decision. It has to know, do I send that packet locally to this local LAN, or do I send it to an external LAN? Is that an external address? If it's external, it has to send it to the gateway. And that's why every network device also has to know the gateway address. So there's three pieces of information that every device needs to have: its own IP address, the network mask, and it has to know the gateway address. Well, first, this machine has to find out what network it is on. And it does that by looking at its IP address, 130.222.18.22. It's now going to use the network mask, and our network mask for both LANs in this example are the same. So here's our network mask. So this machine is going to take the network mask and it's going to AND it with its own IP address, and it's going to get out this. Now, this is the address of the network it's on. So it now knows what network it's on by taking its own address, ANDing it with the IP address. Now, let's suppose it wants to send a packet to this address. What's it going to do? Well, it's going to take the destination address and it's going to AND the network mask. And what it's going to get is this number, 130.300.34.22. And this is the address, or sorry, .0.0. And this is the address of the network that it needs to send its packet to. It compares that to its network and sees, they're different. Since they're different, it knows it has to send the packet to the gateway and let the gateway deliver the packet. If, however, it was sending a packet to this address right here, okay, let's see what would happen. We'll just change some of this information here. So we have 130.222.20.33. We're going to use our network mask to find the network that destination address is on, and what we'll get is this. It compares that to the network it's on and it sees, they're the same. Therefore, it uses a mechanism that we're going to learn later to deliver it through the local LAN to this machine. Now, what's the implication of having a bad mask? That is, what if you made a setting mistake in one of your machines? So we'll consider that. Let's suppose we mistakenly set our network mask as 255.255.255.0. So we made this configuration mistake for this machine. And let's suppose this machine wanted to send a packet. So the destination it was sending a packet was 130.222.20.33. So what would happen? This machine would take its own address. It would AND it with the network mask. This network mask, remember, is mistakenly configured. And what it would get this address. So this machine thinks this is the network it's on. It wants to send a packet to this address, which is a machine right here on its own local LAN. Again, it will AND the network mask. And what it thinks is it thinks that that machine is on this network. And when it compares its network to this network, it says, ah, they're different. And so what it's going to do is it's going to take that packet and it's going to send it to the gateway. It's not going to deliver it local. And so that packet's going to get lost and never happen. So if you have your network mask misconfigured, it can happen that traffic will not get to the proper destination, and many of your applications simply may not work. Okay, so that's sort of how addresses, IP addresses work. And so you can actually test yourself on some of this by looking at this example. Let's suppose we have a machine and you have email running on this machine and you want to send an email to this address. Your IP address, the address of this machine is this, your network mask is this. So what I want you to determine is, what's my network address? What is the network address for this machine? And this machine has to determine, I want to send a packet here. Should I send it locally or to the gateway? So pause this video for a second and determine these two pieces of information and then check your answers. Okay, so let's see what answers you got. Your IP address is here. When you AND these two, it's not quite as obvious because you've got 134 and you've got 128. So let's just look at that ANDing. 134 is actually this number, 10000110, and 128 is this. And so when you AND those two, you're going to get this number, which is 128. So if you look at what is my network address, it is 192. If I AND these two octets, you get 192. You'll get 168. Here, when you AND these two, you'll get 128. And here you'll get 0. So that is the address of the local network. Should I send my packet locally, that is, should I send this packet here locally or to the gateway? Again, we have to take this and we have to AND it with the network mask. And the only difficulty is in the third octet right here. 100 is actually 0110, 0100. So we're going to AND that with 128. And here's what we're going to get. We're actually going to get all zeros. So when I do that, it's going to get 192.168.0.0. Okay, the local address, when the first we determined my network address was this. I'm sending my mail to this address. Those are different, and therefore I should send my packet to the gateway, which is configured. So that's the answer to those two questions.